Hey guys, today I will be discussing about a new data structure, that is graph, and in graph we will be discussing in this session the DFS traversal. So basically this is the most common traversal method used in graphs. So now let's look at this with the help of the example. Suppose we have given this graph in the form of nodes and edges like 0, 1, 2, 3, so on, and the corresponding directed edges from one node to another node. So when we do a depth first search traversal of this, so first I will show you what will be the output that can be generated with the help of DFS traversal on this graph. So if our starting node for DFS traversal is 0, then the one output corresponding can be generated as 0, 1, 4, 2, 5, 6, 8, 3, 7. Now why is this sequence of output is generated? Because as the name suggests, DFS, it will traverse all the branch depthwise order until it hits the leaf node. Once it hits the leaf node, then it will backtrack to the node from which it came from, and it will traverse all the node of that nodes again. Okay, like one more possible sequence of traversal for this is 0, 1, 4, 3, 7, 2, 6, 8 and 5. This is also one possible DFS traversal for this. So first thing you need to keep in mind is there is more than one DFS traversal possible for a given graph. Okay. Now how this output is actually generated, let's dip into it. Okay. For this we have to maintain one array named visited, which will keep track of the nodes which are visited in DFS or not, so that it will not fall in infinite loop. Because if we do not maintain this condition, then the nodes will put again and again in the DFS traversal and it will go infinitely. Okay, for each node we will maintain an array visited with all the values initially filled with false. Now false indicate that this node is still left to be visited. Okay. Now as we are starting with node 0, so we have to make the visited of node 0 as true and put the node 0 onto the stack. Just remember one thing, for DFS traversal we use stack. Okay, 0 is put it into the stack. After that the neighbor of the zeros are seen. So out of these three neighbors we can choose anyone. We are selecting 1 and making visited of 1 as 2. Okay, and put 1 onto the top of the stack. After that we have one node left which is neighbor of 1, which is unvisited. So we visit 4 and make visited of 4 as 2 and put 4 onto the top of the stack. After that what we're gonna do is it gonna hit the leaf node. So we will backtrack from 1 to 4 to 1 and check whether there is still any node left for 1 which is unvisited, which is not is the case in this scenario. So we will put 4 and 1 out of the stack and we will backtrack again to 0. For node 0 there are still 2 nodes left which are unvisited, so we will select node 2 and put it into the stack and make visited of 2 as 2. Okay, so now there are 2 nodes left which are unvisited, so we will select any one of them. Let me select 5 and make visited of 5 as 2 and put 5 onto the top of the stack. Now whenever we hit the leaf node, the thing which we have to do is to backtrack to the node which we have came from. Now for 2 there is one node still left which is unvisited, so we visit that 6 and make visited of 6 as 2 and put 6 into the top of the stack. And for 6 we visit node 8 and put 8 onto the top of the stack. Okay, now as we hit the leaf node we will do a backtrack to a node which we have came from. So we have came from 0. Okay, so for 0 now there is one branch still left which is unvisited, so we will visit 3, make visited of 3 as 2 and put 3 onto the top of the stack. Now just remember one thing, we have done a backtrack up to 0, so we have to remove all this from the top of the stack. So now top of the stack will contain only 0, and it has visited 3, so it will contain 3 also. Okay, so it will contain 3 also. Let me change the pen. Okay, so we have to insert 0 and now 3, because 3 is visited just now, and for 3 we have one neighbor left, 7, which we have to put it onto the top of the stack. Okay, so 7 make visited of 7 as 2. Now for 7 there is no node left which is unvisited, so we'll backtrack to the place which we have came from and pop everything from the stack, and it will return to the main function. Okay, so this is the traversal method in which we traverse each and every node and print it only once. So as and when it will traverse any of the node first time, we have to print that node. So this is the DFS traversal method. Now let's analyze the time and space complexity for this. For time complexity, it will go up to m plus n, because at worst case we have to visit all the nodes with all the edges. So if we have m number of edges and n number of nodes, then at worst case the time complexity will go to O of mn. Also for space complexity, we have taken visited array which is of size number of node, and we have number of nodes as n. So overall space complexity in this case is O of n, and time complexity is O of m plus n. Now we have taken this extra internal stack also, so this will also in worst case go up to O of n. So effectively time complexity will be O of n only. Okay, now let's look at how to code this efficiently. Now let's look at the code of this. For showing the graph, what we have taken an unordered map with the key values as the node values, and the values for the corresponding keys a vector of integer, which will tell us what are the nodes it is directly connected to. For example, for node 0 we have 3 nodes, 1 2 3, which is connected to node 0, like this: 1 2 and 3. For node 1 we have one node 4 which is directly connected to it. For node 2 we have two nodes 5 and 6 with which is it directly connected to. For node 3 we have one node 7 which it is connected to. For node 6 we have one node 8 which is it is connected to. Okay, let me write it down here also. With 2 it is connected to 5 and 6, 3 is connected to 7, and 6 is connected to 8. So this is the representation in the form of unordered map. So the graph is represented in the form of unordered map, and this is the pictorial representation of that graph. So now let's look at the function. Before jumping into the function, we have taken and visited array of size 9 because we have 9 nodes in our graph, and we have initialized all of this with the value false. So here we have 0 1 2 3 4 5 6 7 8, which is 9 nodes, and we have initialized all the value of this as false. Okay, after that we will call DFS on the graph 0 with visited starting node and the graph. So now let's look at the method of DFS. So here we have written one method for DFS. Let's look it out. Okay, so let me erase this. So we are calling this function DFT with depth first traversal with input as a graph in the form of unordered map, the starting node from which we are starting, in this case it is 0, and the visited array which will keep track of the nodes which are currently visited. So we are starting with 0. We will print 0 as our output first. After that we make the visited of 0 as 2, and for each node of neighboring node of this node 0, what we are doing is, if it is not visited, we are calling this function again with that particular node and the visited array. So in this case 1 is not visited, so we are calling DFT with, so let's me write it down again. We first call the DFT on 0, after that we visit after that we visit 1, 2 and 3. Now we will put DFT of 1, and after that we visit 4, we put DFT of 4 and make visited of 1 as 2 and visited of 4 as 2, and also we are writing this as our output. After that, once we have no node left for 4 which is unexplored, we will pop this function from the top of the stack and pop 1 also from the top of the stack. Okay, so these two are visited. Likewise, recursively, what we're gonna do is we're gonna visit 2, make visited of 2 as 2 and put it in the stack, and so on. We are printing all the elements of the stack. Let me write it down: 5, then 6, then 8, then 3, then 7. If you follow this function recursively, you will get this type of output. Okay, so the thing I am considered here is the graph is represented in the form of unordered map. Also, once the node is visited first time, I am printing that node, also make visited of that node as 2, and for each neighbor that is not visited, for not visited, I am calling this TFT on that node. So basically this is a simple code of DFS traversal. Okay, and for analyzing the time and space complexity, we are traversing each node once. So effectively time complexity is O of m and m plus n, and the space complexity is O of n, because we have taken extra array visited. And just remember one thing, we have passed both the graph and the visited in this function as an reference, because if we pass this in by an object, then it will copy again and again and it will took time. Okay, so just keep in mind, pass it by reference. Okay, that's it for the today's code. In the next code we will discussing about another search traversal algorithm, which is BFS traversal. Till then, stay tuned. Tata, bye bye.